let's take a look at one more example that's a little bit more complex still in a different way. This time what I've done is I've actually created, if you think about the graph, like a little bit of a phase shift of what's going on in here. But once again, I'm going to take this whole package and I'm going to call this u. So I'm going to say let u equal x minus pi over 6. And then I'm going to make this substitution, and it's going to look a lot like before. So sine of u is going to equal negative 1/2, and just like before, u should equal 7 pi over 6 and 11 pi over 6. All right, and let's go back to our substitution. So now we're going to put x minus pi over 6 back, and I'm going to say that's equal to 7 pi over 6 and 11 pi over 6. And if I were to solve this, I'm going to think, well, I'm going to add pi over 6 to both sides. So I'm going to add pi over 6 here, and I'm going to add pi over 6 here. And I'm going to keep everything. I'm not going to reduce any denominators yet. I think it's easiest to just reduce all the way at the end. That way it's easier to find more solutions. So this is going to be an 8 pi over 6, and this is going to be a 12 pi over 6. And just like before, I'm going to rewrite these restrictions in terms of pi's over 6, since that's kind of what I'm working with here. So I'm going to say that this 3 pi over 6 is the same thing as 18 pi over 6. And this is kind of like the number I'm trying to hit. So now let's start adding periods. And my period is going to equal 2 pi. So x is going to equal, I'm going to start with this solution here, 8 pi over 6. And I'll start with this solution here, 12 pi over 6. And if I were to add a period, which is 2 pi, in this case I'll say that's equal to 12 pi over 6, I'll come up with a 20 pi over 6, which is already too high, so this is not a solution. Okay, that's good. Now let's take a look at the 12 pi over 6. If I were to add a 12 pi over 6, I would have 24 pi over 6, and that's also outside of my domain. That's not going to work. So it looks like these are my only two solutions. However, now I just need to be careful and remember that I have shifted my original solutions. So I need to actually, sometimes I might need to check for subtracting the period from my solutions. So actually, what would happen if I subtracted 12 pi over 6 from any of these solutions? Would I still be within my domain restriction? So let's actually check that. If I were to subtract 12 pi over 6, I would have a negative value. That's not going to work. However, if I were to subtract a 12 pi over 6 from 12 pi over 6, I would have 0. Well, 0 is within my restrictions, since this is 0 is less than or equal to x. So 0 is also a solution to this equation. So what we need to now do is let's just clean this up a little bit. Let's list all of my solutions. X can equal 0. Now I'll reduce this to 4 pi over 3. And I'll reduce this to 2 pi. And that's it. So things are getting a little bit more complex, a whole lot more that we have to keep in mind. But these are really the kinds of differences that we can add to these problems. We can shift our graph, so we can change the period, and that's going to cause more or less solutions within our domain restriction. So that was a whole lot to take in, but why don't you try one of these for yourself? Here I have a restriction from negative 2 pi to 2 pi. Pause the video, give this one a shot, and see how it goes. All right, and here's my solution. I tried to lay out my work for you here. I used the u substitution, and if we keep in mind that the period is 4 pi, and we're adding and subtracting 16 pi's over 4, we actually only end up with two solutions that work out, and that's that 3 pi over 2 and negative 3 pi over 2.